final speaker of the day is Mr. Vaibhi Prakash. He is the head of Technology Transfer Office and Product Labs at IIIT Hyderabad. He runs the Entrepreneur in Residence to pre-incubate startups and teaches technology product entrepreneurship at the institute. Prior to IIIT, he was the investor and founding member of Wooker, a Bangalore-based startup. He was the vice president for research and development for Acme Telepower. He was the director research and technology at Honeywell India at Bangalore. So without any further delay, let's welcome Mr. Vaibhi Prakash. Over to you, sir.
Thank you. Thanks a lot. Good afternoon, everyone. So today I'll be spending some time sharing how one can take the research output or technologies. You can see my screen, I believe. Can you see my screen?
Yes, sir, it's visible.
Yeah. So today I'll be spending the next couple of hours on two aspects. How do you take research-led innovation to the market? And I'll back it up with a set of case studies or examples on different ways in which certain technologies we have taken to the market. And also when I'm talking about each of these technologies, I'll try to give some context on the business opportunities beyond what we have realized. For example, I'll take Industry 4.0 as one of the focus areas, and I'll see same technology, how it can be used in other domains like Industry 4.0 also. I'll try to highlight. Okay. So if you look at it, the fundamental issue is this gap, right? There is research happening out there from the lab, and it needs to go out to the land. It doesn't happen as one wishes it to be. This problem we have studied quite a bit at the institute, and we realize that good news is we are not alone. I think the problem is there internationally across academic institutions. And of course, it might be slightly better than the Indian ecosystem, but the problem remains the same. The core problems remain same. The fundamental issues, what we have seen is the research connected to the real world? So are we solving the problems that the real world wants to solve? I think there's a big gap, because as academia, as technologists, we try to solve problems that give us technical satisfaction, technical kicks. But the connect to the real world is always been a challenge. The second, what we have seen is, okay, there is a research output, and there is no way it communicates back to the land, that is users, be it a startup or an industry, how they can use it. What is it? How they can put to use? What does it mean to them? So that communication doesn't go. Most of it targets the academic community. The third problem we have seen is the demos or the prototypes that are made most often are technical demos that do technical demonstration. The demos do not convey a market use, do not convey how someone can put to use in the real life or in a social use. The last one is, there is a lot of talk about startups coming out of research, and then there's a lot of push for faculty to become entrepreneurs. One thing that we have really because that is based on a few examples in the Western world and a few in India also, we see them. The fundamental conflict here is the faculty have come there to teach, they come there to do research, right? And you suddenly ask them to become businessmen. So how do you solve the problem? But the knowledge is with them. They are the ones, they're the real ones who can really crack the technology that is useful for the society. But then should we ask them to become entrepreneurs? Not necessarily. And one more thing that that I missed in this is, especially this is a problem very specific to IT world. The technology is changing so fast. There are a lot of things coming up, and most often the faculty's interest in problems keep shifting as technologies have evolved. That means what you have worked 3 years ago or 2 years ago is no longer the same now, because you have moved on to a new problem, and it becomes even more complex because your set of students who have been working with you have now left the institution. They're somewhere else. There's no one else continuing the research, and you're with a new set of students. You're working a new set of problems, right? So this very very strongly applicable in the IT space where the technology moves, changes happen pretty fast. So we looked at all of this, and this looked at these challenges, why certain things are happening the way they're happening. Then we said, let's flip it around. Instead of telling our faculty to go out and go and create startups or create products, we said, why don't we bring the market and startups to the faculty back? So, of course, then that means one needs to, research is always a starting point. One is identify the markets, identify startups, create infrastructure, have conversations. That's where and have conversations with entrepreneurs and industry, and then bring all of them back to the faculty and engage them with the faculty rather than asking faculty to go out and create startups. So that means one needs to, as institutions, you need to have structural enablers like you should have research centers. We created product labs. I'll come to each one of those things. Right? There should be a massive outreach, and one needs to have incubator, right? And you should have a technology transfer office. Having this is not enough. One also need to look at different models of innovation, different models in which you can take these things out. Those are some of the models that we implemented. I'll talk about in the next couple of minutes, right? That means one needs to study the innovation process, what is happening there, right? And figure out study how product seeding happens, how you innovate together with other people. That is what you call it as co-innovation, right? And how do you conduct open innovation? All these models need to be studied along with setting up these infrastructures or the enablers in an institution. So for us, I think the first enabler for us is having an academic incubator. In our model, the difference IIIT follows. I think the different approach IIIT follows in the academic incubator is two things. One is it's an open incubator. That means anybody from anywhere can come and create their startups. It's not limited to the institute's students, institute professors, or institute's technology. That makes a huge difference when you open up your incubator to everyone, not limiting to your own people. The second focus is incubators should be run by people with industry background, and of course, since it is part of an academic setup, there will be an academic council giving the guidance. But end of the day, the people running it should be from the industry, because you need an industry mindset to run an entity like an incubator, because there are a lot of business aspects that need to be looked into. The second one was the different models of engagement that we need to put in place for the startups to interact with the faculty. So what we did was there is no one size fits all model in which startups can interact with the faculty. That means we have a program where startup can do co-research with the faculty. That means give a research problem and get the faculty to do the research and consume it. Other model, of course, is not just licensing, but also as an institution, help the startup to build the MVP itself based on your technology. Co-creation is not just doing research, but also co-create that MVP together with the startup. The fourth one, which a lot of people follow, is making sure every startup that is incubated or engaging with you, you pick those startups that need research advisory, and deeply focus on startups that have alignment with the technology, and make sure that the advisory of the faculty reaches these startups. And the last one is, of course, creating startups itself, creating products and startups itself, and then finding entrepreneurs to take your product from your research labs. So this is one set of startup engagement models we have put in. The other one that we have put in place is, because if you want to have impact, you cannot be all over the place. You need to have trust areas. You need to have as an incubator, you say, okay, I'll focus on medtech, I'll focus on, let's say, pharma industry, or I'll focus on social innovation. So you need to have those specific, of course, as an incubator, there'll be other general startups that are hosted in your incubator, but then you need to have deep focus on certain technology thrust areas or certain horizontal areas, or we'll focus only in fintech, we'll focus on medtech. So that actually what happens, and what it does is it brings in a lot of forces together. Faculty who are interested in these areas come together. The startups, the investors, the mentors, all of them come together. That creates a rich ecosystem wherein the right problems go to the academia, and academia also are working with the right set of people who will take technology to those specific domains of their interest. Because at the end of the day, faculty, though they are doing research, but what we have observed is there's a lot of passion to see the technology out, but they don't see themselves doing it. And there's a lot of passion to certain areas. I want to do this in education space. I want to do this in medical space. So having these trust areas gives that kind of engagement with the faculty and the startup to take things forward. So the other one is one can always do commission research, as I talked about. More important thing is trying to co-create. Co-create is where the co-creation or co-innovation is really the place where you build technology along with the startup brings the problem statements, and the faculty brings in the research expertise. Together, they are creating the technology and creating the market solutions. What happens is, as the startup is engaging in the market, they're giving the real market feedback back to the faculty, and they're fixing those problems. And then the relevant technology is getting built, and the probability of hitting the market goes much higher. So this is something that we see are happening almost in every one of our program as we take startups into our acceleration programs. So the other one is having an open innovation model. I think here there are a lot of open innovation models people talk about, especially the corporates, working with the corporates, solving the corporates technology challenge. Here we have slightly changed this year. We said we will take up we will do open innovation on corporates problems, wherein the problem can potentially be addressed from the technologies that are being developed in the lab. So that means the problems and the technologies that we're developing, and more or less there's an alignment even before we do an open innovation challenge. So we go ahead, we pick those problems, we launch a challenge, we get the startups and students, innovators to do those hackathons. And once you have shortlisted those set of people who have hacked those solutions, the next step is something we do slightly different. Is we, as a process, we say that these selected startups or individuals are given connected to the research teams, so that they co-innovate and then move to the next round, wherein the company can use these technologies. So this little process change has helped us a lot because again there is because these problems, we are more or less sure that some of these technologies can address these problems. That means there is an alignment of these problems with the technologies that you are working in, and it also has a very interesting side effect because the professors who have been engaged in some of these open innovation hackathons, they try to no, this is what the industry is looking at. This is what the startups are looking at. So there's a higher probability of them to fine-tune their research problems and then start doing more relevant research. And before doing this open innovation interaction, wherein we identify complete problems, we also do before we even start this, we do an interactive session wherein Uh, we bring to the room the startups, the industry folks, and our faculty and some of the government agencies together in one single room, take a theme, and then in fact, the faculty speaks only for 5 minutes on their research area, but most often it's an open discussion wherein every one of them are putting their problems out there, telling that these are the problems we are solving for which we do not find a technology and we want technology. These sessions precede this open innovation hackathon challenge that we launch. So if you look at it, there are rich interactions happening from end to end in this kind of a model. This is something that we hear. This is where I will be spending a lot of time today. So and this is the reason I joined IIIT. What we have seen as an institution in the last 20 years, there is a lot of technology. And you have the classical technology transfer office that is trying to push it out into the market through the classical sales channel. But what you see is we saw two problems. There is a problem of discovery. That means nobody out there knows what are those technologies available in the institute. Second, it's not in a language that an industry or a startup can understand. The first thing we did was we cataloged everything and we put it in a language that the industry or startups can understand. So that's the first step, and we create technology catalog. We made it live and we share it to everybody out there. The second problem that we have seen is the research scientist develops a technology. It's in MATLAB code or it's in Python code or there's a paper at the end of the day. But the recipient is more an engineering kind of a person who wants this to be translated into a form that he can consume it. And he does not have the capability to understand papers. He does not have the capability to understand some of the MATLAB code. So someone needs to bridge the gap, right? There's nobody to bridge here. And second one is the startup or the innovator wants a generic technology to be applicable to his use case. For example, you develop an optical character recognition. It's a general technology that will identify handwritten optical character recognition. But the startup here, let's say, is into processing KYC forms. That means you're dealing with specific banking related OCR here, right? So you need to fine tune the model to that particular requirement. Now, the faculty are busy doing something else. They're not ready to do this translation work. So most of it falls between these two cracks. So what we did as an institution is we transformed the current technology transfer office into what we call it as product labs. So we created a product lab, which is basically a translation team, which does two things. One is which not only catalogs, it does market study. It identifies the market use cases and then creates market relevant prototypes. That means it does the engineering activity so that the technology is usable, and also works with the startup to help create the MVP along with them. So this is a big investment the institute has made. Almost in the last couple of years, I think institute has spent about ₹1 crore to set up this kind of a lab which does the translation work. Then we said, fine, product labs is one part of the story, but then that's not enough. You want this to go out into the market, and we said we'll focus on creating startups. So to do that, we launched this program called a fellowship program called Entrepreneur Residence Program, wherein given this POCs, given this technology base we have, we start scouting for entrepreneurs who want to build companies out of these technologies. And we not only do that, we also, because IIIT has a large connect with the goodwill and connect with industry, we also bring in the industry who might be potential consumers of this technology, and then align them with the startups so that the relevant product for the market is getting built, and before they exit the fellowship program, they already have potential users of these technologies. So this has really helped us over the last. This is an experiment we have been doing last 3 years, And the first 1.5 year was in cataloging everything that we have, understanding how faculty work and all that. So in the last year and a half, I think we are able to seed about 10 to 12 startups in different models. So how we go about doing that? How do we go about the product lab process? It's a 4-step process. So we use a classical technology readiness level scale. So most of the research is in technology readiness level 3, and then the next step is where we get involved. The product labs get involved in creating this market curated prototype. So here we have a bunch of people who are market facing people who look at the technology, study the market, and see what kind of use cases this market can solve. We aggregate that, we generalize it, and try to create a general market prototype and take it to the next level, which is TRL6. So this is where we spend around 2 to 3 months in this. Then that's the next step. That's when we launch the EIR program, look for entrepreneurs, and then we work closely with them in building the minimum viable product, and then seed the startup. This is anywhere between I would say now it has changed, anywhere between 6 months to 12 months kind of an interaction to take it to the next level. And then once the startup gets incorporated, we have put in a lot of mechanisms where the startup get different grants, different fundings, and we provide the faculty's technologies that has gone with the startup. The faculty is available either as a co-founder, as an at-risk technology advisor, or as just a consultant through their startup life cycle. So this is a typical process we follow in the product labs or the pre-incubator. I would call myself as a pre-incubator of the institute. So to do all of this, we have put the institute has put a lot of enablers. We have started the program called Productizing Research. There's a grant that the institute gives to the faculty, wherein the students who are the first criteria is the professor should say that I want to build a product out of this. I have done enough research and I want some support to build the product. So we waive off this tuition fee and also give RA-ship to the students who are working on the product. And then that's when product labs gets involved and give the student and the faculty some amount of, that means at the TRL3 itself, we try to give that boost that is needed, because it's and the second one is the product lab that we talked about, and the entrepreneur residence program. These two we just talked about. The other one is also, it's also important to have a dedicated commercializing entity we call it the Research Park Foundation, which is very important for you to manage the revenues, manage the equity that is coming in, and then have a purely commercial oriented thinking that needs to be brought into the institution. Of course, the incubator, I think if you want some of this, we strongly feel startups are the ones that can really take some of these things out into the market rather than large companies. Because in large companies, most of the technology sits in the shelf and takes many, many years to go out, while a startup is hungry for business, and the probability of technology going out is much faster through a startup. That's a bet. Of course, 1 in 100 may succeed, but still that's a bet we are willing to take. The last one is we need to have there are different funds, grants available with the government to support startup innovation. I think applying for those grants and making these grants available to your entrepreneurs is very important. These are some of the enablers that we have put in place. So now I'll move into specific examples, specific case studies on different technologies and how we are taken forward. I would like to pause here for a few minutes to take some of your, if you have any questions, I would like to take a few questions, and then I'll move into the case studies. Anybody has specific questions before I jump into the specific case studies? So this is more on the. Okay, I'll carry on to the presentation. Right, thank you. So let me take this first one, right? This is a technology that we nurtured in the product labs along with an end user engagement. So the technology that was available in the labs was as computer vision based technology that understands broadcast videos and analyzes different I would say shots that a player is playing, the distance traveled by a player or and the position of a player. So it is basically activity tracking, people tracking in broadcast videos. So we took this technology as product labs. Then we said, how do we take this forward, right? Because since it is sports and this since is dealing with badminton, and we went to Star Sports. And then we looked at the Premier Badminton League. Product Labs worked with Star Sports in the context of Premier Badminton League, and the same technology that is there in the lab. This was if you look at this was an offline technology. This technology was being used after the Olympic game was over. You analyze and you make it available. That's a good research paper. But what does PBL want? What does Premier Badminton League want? They want moment, let's say PV Sindhu finishes her point. At the end of the point, within 5 seconds before she plays the next, before she starts the next serve, they want to show how many shots she hit and then how many, what's the distance traveled by PV Sindhu. That means we need to translate. That's what the market wants. That's what the broadcaster wants, because these analytics are useful for audience entertainment. So we went ahead, we worked with Star Sports on the live stream. Now the whole thing is about how do you transform this technology in a way that it works in live stream and gives results in real time versus offline. So that's where Product Labs got involved. And then in fact, we demonstrated that, and you will see some other, every Premier Badminton League, you will see some of these analytics coming from IIT's technology. And then we found a couple of entrepreneurs who wanted to take this forward as their business. We put them to our EAR program. And all through this, Star Sports was giving their inputs because they built a goodwill. We built a goodwill with them that, yeah, these people are genuine, this technology is good and all that. While we were doing this, when we did a market analysis, we found, yes, broadcasters is a good market, but there's a huge market available. That's where the entrepreneur comes in. There's a huge market available for amateur and semi-pro athletes who are trying to learn the game, who want to. That's where the academics come into place. Academy. So there we tied up. We went to Pulela Gopichand. We went to and we said, this is the technology we're building, and this is a startup that has come forward to take it forward. And now our market analysis says there's a huge opportunity in semi, because we already had a product for broadcasters, which is good. That's a niche market. We said we want to make this technology big, so we said we want to go here. So he looked at it, he is impressed, and he gave us some challenges, telling that, can you analyze these different types of shots? Then that's where the professor and the startup come together, and they started enhancing the technology for an academy use case. I'll tell you how the academy use case is. In a broadcast video, the videos are clean, high definition. Players are wearing different shirts. You can easily identify them, right? When it comes to an academy, most of them are wearing white shirt. There's a lot of noise. The camera position is not exactly the same way that is positioned in a broadcast. The camera keeps changing, right? And the compute power available for you is much lesser at an academy than that is available for a broadcaster. And so the way the coaches look at the data is completely different, because coaches are looking for performance analysis. Broadcaster is looking for entertainment purpose. He wants to entertain the audience. So they worked with him. They built a new product, and he has used it to analyze Indian players' performance in the world championships and all that. And now we are in a stage where Pullela Gopichand himself has become a co-founder of this startup, and then they're going to expand into the market. So this is something that we have closely built this product with the end user engagement in product labs. The second, this is another interesting product. This is something that we have co-created with the market, that is with SBI. So this is a technology that professor in natural language okay. So now coming back here, where else can we use this technology? This if you look at it at an abstract level, this is people activity tracking using cameras. Now this is becoming more and more important in Industry 4.0 applications, where they want to understand the movement of workers more from a safety point of view. Are they violating the unsafe, getting into unsafe zones? Are they doing things they are not supposed to do? Are they putting their hands in the wrong places? So at the end of the day, if you look at it, some of the core components are people activity detection and people movement detection, people tracking. So they're applying this in a similar kind of the core of the algorithm is still applicable in Industry 4.0 for understanding how people are working in a factory shop floor. Right now, this is, if you look at this, this is a technology that our Professor Manish had worked for many years, wherein you will be able to query a document in your natural language. And the beauty of that is you do not have to create domain specific models. That means today, a lot of document querying engines, you spend time building a domain model for healthcare documents, and then you put the document, query them, fine, you get reasonable answers. Otherwise, what is available to you is Control F to search into documents. So here he has built the model. You just dump in a bunch of documents. You don't have to throw in any model ontologies or anything like that. And then you are ready to go and query these documents in natural language within minutes. So this particular technology is available. Then SBI was looking for a solution wherein they had a lot of, circular RBI. This is very, very pertinent in the case of RBI circulars. There are a lot of circulars and notifications, and also SBI's own products. They create manually look at those documents and create FAQs. And these FAQs, people access, the employees access to answer some of their questions. They said, this is a painful process, a long run process. Can we build a cloud-based solution that will help us just dump in the documents, and then we don't want to do any of this FAQ business, and then let people get their questions answered on their own, and then let those most frequently answered questions are made available to the subsequent users. So this is something, and a similar problem was there in BDL. Bharat Dynamics, this is where the Industry 4.0 comes in. So if you look at if you look at in a lot of industries, a lot of knowledge base, especially user manuals, are there in documents. So a person who is in the field is trying to ask questions. He wants trying to solve problems whose answers are in a document. So now, if you look at in a high-end industrial scenario like a missile, the Jawan on the field picks up a phone, calls someone in BDL, and says, "Sir, I'm facing this problem. This red light is glowing. What am I supposed to do?" Now they said, "No, this document bot is going to ingest all our manuals, and then the guy in the field is going to ask and get his answers. If he still doesn't get his answers, then he's going to pick up the phone and call BDL or any of this." So if you look at it, this has a vast application in the Industry 4.0 scenario, where the knowledge is residing in document. Now this also has become a startup, and they're going great guns in the both the industrial space and also in the banking domain. This is something very interesting. So you'll come across a lot of scenarios where it is a student who has the idea. Because students have a lot of great ideas. And how do you give shape to the student innovation? It's not just the professor who's working on it. It's a student, even how do you give shape? This is an example where we're taking student innovation through this process. So the student had come with an idea telling that when a drone has to carry different payloads, for different payloads of different sizes and capacity, you need different sized drones because single drone cannot address. Why? Then he said that is because you have a fixed size rotors and the drone is a fixed size, and all they do is they attach a little container below it, and then you put your packages in that, and then you end up creating very unstable drones. He said, why not I create a flexible drone which expands to the available package, clings onto it, and then takes off. And then a professor in robotics, he said, hey, this guy is the way he's approaching this problem is great, and he's my PhD student. So can you guide this guy? So we took him through, took the student to a technology product entrepreneurship course. We took him through our fellowship program. We worked with him closely, gave him the market inputs, and then at every step shaped his drone because this is a very generic technology. And he said, now we shaped this drone so that it can be used in last mile logistics. That means, let's say to the warehouse, you have the equipment as the products have come, and from the gate, now you want to take it into the respective slots. And these packages have different sizes. Or in a residential community, the different packages will come to the gate, and then from there, or it could be even a SEZ. From there, you want to take this to, or even take to the respective buildings or houses. In the agriculture space, you use different drones, one drone for spraying, one drone for fertilizer, one drone for monitoring. So this drone has the capability to. So we looked at all these opportunities, and then we are shaping this drone in the context of last mile logistics and warehouse logistics. This is another interesting product. This is again a technology. This is something where it's a mat that has sensors built into it, and once a human being sits on it or sleeps on it, it measures various parameters, and then you can monitor the health of a person. So this one we are taking a platform approach, hardware platform approach rather than a point solution, because these kind of technologies are multi-use technologies. They can be used in physiotherapy clinics, right? A person comes in, he lies down, or it can be used in a patient's bed. It also can be used as a lifestyle product. It can be used as training in sports. So we're creating it as a generic platform which can be embedded into any mattress or any surface. So we have a chair manufacturer coming in telling that I want to make my chair, because all these people look at it. Furniture people, most of furnitures are passive. They want to move towards more interesting and active furnitures, and then make it a health and lifestyle product. So there is a chair manufacturer who wants to embed this. There is a mattress manufacturer who says, it's not just another mattress you can sleep comfortably. I'm going to create a mattress wherein we can measure and analyze the health parameters, and then so this is one very interesting product that's taking a hardware platform approach. This is again by the professor and the students. They created a startup, and then it's going through the stage. And this productizing is happening in the lab, where the product lab is playing the role of a business mentor to the startup. This is another two interesting technologies. Why I brought them here is because this has a great wearables have a great relevance to Industry 4.0. We are seeing more and more industrial applications where people are beginning to use smartwatches, smart bands, wearables to monitor the state of mind, the health of the industrial workers. In the current COVID situation, they want to measure temperatures, different body parameters, right? There are multiple parameters people want to measure from a safety and health of industrial workers. And we see a huge opportunity or offshoot of this technology. However, these are healthcare, because at the end of the day, I'm measuring health parameters. One technology to the left is a professor has built a BP meter wherein using ECG and PPG signals, you can get continuous BP. today most of the so-called continuous BP meters that are available measure BP at a point in time, and then they average it or use simple algorithms to interpolate the data. But here, using this signal, it can give you a continuous BP, and this is very useful in the case of understanding health of sports people, understand the health of people with arrhythmia problems. So this technology was in the lab, and here we directly connected with the startup. And then the startup and the professor, or there's no product labs here. Our job was only to connect to the right startup who will take it forward. The professor and the startup are working together to create this product that will go into a device. Contrast this to the right, wherein the startup had a idea. The startup said, I want to hear the murmurs of a baby in the stomach of in the womb of a pregnant woman. So I want to measure those cardiac murmurs of a baby. So I want to make a wearable. So the startup's idea, and the startup said there's a huge business case for this. Now the professor came and said, okay, I'm interested in this problem because I do a lot of embedded IoT kind of work. And now professor built the technology for the startup. Startup only had an idea, had a business case, and the professor built the technology, and we licensed the technology back to the startup. And as you can see, such a variable has again several. So these are two different approaches way of co-creating a startup, where you have a technology and then you find a startup and then you create a product with the startup. The second one is startup as an idea, where you have the technological know-how and then you are building that for the startup and then taking it out. But both are, if you look at it, co-creating with the startup. This is another very interesting trend that is happening in most of the government-funded projects, especially in MIT. Almost every government-funded project is now telling that not only we are funding you not only for research, we also want you to come out with products and also work with startups or seed startups. So if you look at in the language technology, or we have this program called the Living Labs program, or there is an iHub data program. There are multiple programs where in almost every MIT or DST is now beginning to insist on creating usable solutions. It could be a social solution, or it could be a commercial solutions, and creating startups. Now, for a initial period, we were looking for startups, and then we have been engaging. But now we are at a stage where there's enough technology built. The professor himself, because having worked with the startups in the earlier context, the professor himself now is telling, I'm going to build my own startups out of this technology. Right now, one of the professors is building a water monitoring system which can retrofit into. So if you look at this, is anyway straightforward fitting into Industry 4.0, where you are measuring different utilities and then communicating over the IoT network. It could be water, it could be indoor pollution, outdoor pollution. So as you can see, this is something that you are coming out of the government-funded research and being taken forward as startups, wherein the professor is a co-founder of it. In fact, the student is the founder and the professor is a co-founder, and then they're going ahead and building the company. This is something that we have been thinking for a while, and fortunately we had good funding from MIT's Bashini program. Not every technology can become a startup, right? There are a lot of small, very interesting nuggets you do out of your research, and then you end up in a situation where it can't become a startup, neither is licensable, but there are people interested in using this. So how do you take this forward, and how do you monetize it, and how do you motivate the process here? So what we have done is we have built something called an API gateway, application program interface gateway. All these components, we have put them behind a server. We talked to the professor, we created these components, we created APIs, and then we put them behind a server infrastructure and made them available through a gateway for the rest of the world to use and the rest of the world to build solutions on it. Or someone just want to do a little bit of a translation, English to Hindi translation. Just we provide small widgets they can use, or they can directly hit the API and use their and we put them, and we are right now we are in the process of putting a monetizing model, billing model, and all that. So right now we have the gateway with all the technologies behind. Of course, the biggest challenge is having a good server infrastructure. You need to have a good server infrastructure. Unfortunately, MIT's Bhashani program is putting up large infrastructure in CDAC, which we will be leveraging. At the same time, we have convinced the institute that look, we need to also put our own infrastructure for our own commercial purpose, and the institute has agreed, and we are putting a few good high-end GPUs and servers dedicated only. Most of the institutions you deploy the server infrastructure for their research purpose. Now we have dedicated this for deployment and application purpose. So this is a little change we have done, and then we are beginning to see traction. Because what happens, a lot of people try out a technology, like it, and come to you and then get it licensed. Someone may say just want to use it for a few instances, pay you small monies, and then get their work done. So there are many such use cases which we are beginning to address using this API gateway approach. This one is this is a technology which what you call it as it's a lip sync technology. It falls in the category of deep fakes. That means like if you give me a video, I can put anybody's voice on your video. As simple as that. I can put words in your mouth. So this is technology that has been built in computer vision lab. So it works on any face, any voice can be put, any language. So it's a very one of the best lip sync technologies we have in the world. If you want, you can go to YouTube and you see Drake's knife talk video, which has around 28 million hits. That is from IIIT's lip sync technology. Here, what we have done is, this is a very sensitive technology, and we wanted to put a lot of control on the technology because this can be misused. I can take the Prime Minister's voice, and of course, technology has not evolved to a point where I can put his own voice, but I can put any words on his. It could be a synthetic voice. I can put any words on the face. So we wanted to avoid that, and we put it behind the firewall. And then what we did was we created a virtual startup. That means the startup is in the institution. It's a set of engineers who are operating like a startup in our Research Park Foundation and delivering the services. And so now that is becoming a startup now, because institutions can only hold it for a while. But this gave us the runway to manage a lot of issues that will come with this kind of a technology. And then we figured out a few things that will make this technology more robust, and also this also has generated revenues into the institution before it moves out as a startup. So this is something that there's a new model we tried, and it is working well. And the last one is I talked about all about commercial applications, but now when you say lab to land, it can also be social innovations, right? It may not just be commercially oriented. So we have taken our language technologies, machine translation, text to speech, which we are in the process of piloting with Augusta Foundation. This is a technology wherein a student in rural areas right now, they're trying it out in Kuppam village, in Kuppam and other Chittoor district, wherein the student picks up the phone using the Ask Agastya number. He asks a question on the phone in vernacular language, and then that language is translated to English. Question is translated English. Then we use the document bot that I talked about, and then the document bot has all the curriculum textbooks sitting in it, and it queries, gets the answer. Right now we have a human in the loop. There are teachers in the loop who are verifying, because many of these technologies are still evolving. They're verifying, they're more acting as a quality control, verifying that, okay, this answer seems to be right, and pick up if the answer is wrong, you correct the answer. And then that answer is translated into vernacular language back, and then it answers back in speech to the student. If the student is not able to stay on the phone line for a long time, he can disconnect, but the system calls back the student telling that this is a question you asked, and for this is the answer. So this is a great social application for a lot of students who do not have direct access to teachers. The second application in language is using technology to help students pronounce different languages better. We're starting with English. So how does a student improve the spoken proficiency of English language? It's a small app where a student speaks into it and it understands what he has spoken and says the pronunciation is good or bad, and then gives him a small feedback. The last one is we built a healthcare screening app wherein you collect the data, and the data is used for the collect various cancer related. It's basically used for oral cancer. It's an application we have built with Grace Cancer Foundation. So then the Anganwadi workers go take pictures and then send it back to our servers, and then we do that analytics, and then the Cancer Foundation looks at some of this data and then provides insights back on if the person has cancer or not. So there are some of the social applications. There are many such social applications that are coming in the pipeline. I just picked up a few things. So the point is, when you say prioritizing research, taking lab to land, it need not be commercial. It could be a bunch of social applications. This is where the virtual startup comes, because finding a startup for this might be difficult. There are few social innovation startups, and they're still evolving. They're coming forward. But then, as an institution, you find you have a social obligation to give such solutions. So that's where we host it on our API gateway. You make it available to the virtual startup mode. Have your bunch of engineers who are supporting these end users of this. Most of this, if you look at all these, are NGOs. And these are tools that are enabling NGOs to go and do their work more efficiently in the market, and it's backed by some deep technologies. So to conclude, yeah, there are several models we're experimenting, and I wouldn't say that we are the masters of it. We are learning, and every time we keep trying a different model, and that seems to be working for us. And we see uh, uh, technologies can indeed be taken to the lab, but then there need to be models in place, experimentation, willing to experiment, willing to invest, and put dedicated people behind it. So I will stop here. I'll stop my presentation here, and I'll take questions. Yes, variables that can do. Is it there in IIIT? No, but yeah, it's possible to build such variables to uh, to do REM sleep duration and time. I think some of the smartwatches are already doing it, but I think these are commercial consumer grade, but there are technologies that can do that. Yes, can AI translate English content to? Yes, if you look at in the Bhashini project, I think the question was, can AI translate content to regional languages, and NPTEL courses, the Bhashini program, and there is also a program supported by Principal Scientific Advisor's Office. So that entire program, I think a big chunk of the program is about translating NPTEL lectures into regional languages. So if you look at if you see a lot of NPTEL lectures out there that are translated, a lot of them have come from this program itself. Yeah, so a lot of, if you look at, yes, I think that's where, if you look at some of the language translation, generic domain is Google's and all that work very well in generic domain. But when it comes to scientific domain, when you want to understand engineering terms, there are a lot of specific terms. That's where rich data sets are very important, because most of them are using neuro machine translation kind of techniques, and it's all about the amount of again the Bhashini program does it, and the data sets are going to be, AI is not going to coin new words, but AI is, you are going to collect this data set, create the corpora, annotate the data sets, identify the domain terms. Once that is in place, the models are going to learn and pick up those relevant things. Bhashini program, if you, I'll just give you, you can search for Bhashini at, 1 minute. I'll just share the link. Yes, Irene,
Yeah,
Pereira.
thank you. I thought my turn is never going to come. Okay, I really am so envious. First of all, thank you. It was a really great session. I teach in a college of higher education in Secunderabad, St. Anne's, and a lot of our students are minority students coming from the Telugu background, and I don't speak a word of Telugu. And yet I teach because the B.Ed and the M.Ed programs are English medium. And my heart goes out to them because I'm almost handicapped. And I'm jealous of all these people who know computer programming so that they can design their own compilers and their own language modules. How can you help me? Where can I find because Google Translation, I tried really hard and they tell me that it's okay, ma'am, we can find out what it is, but it's really not a great translation. So really we struggle with regional languages, translation in the regional languages. And there are not really good books, like we have textbooks in English. I haven't found books in Telugu. So how can you help me? Can you suggest something where I can overcome my handicap, my this language issue? The next choice is to learn Telugu at 63, yeah?
Yeah, one is, I think since we are in Hyderabad, our Professor Diti, who is heading the language translation mission for the machine translation mission she's working on, we can definitely interact with her, and then she is the expert in that space. There are, that's one of the missions. I think the Bhashini's mission is someone speaks in one language and you should be able to hear in other language. That is a whole mission for the next, I think it's a 3-year program. So there are several technology components that are in place. So one is using some of these language translation technologies, which are very specific, because some of these technologies built keeping education domain in mind, because most of the data sets are in the education domain. So your translation accuracies will be much higher compared to Google, because these are domain adapted for education. So using some of these engines will help you in taking your English or English query and translating into Telugu. But technology is still not mature enough for it to be 100% accurate, but at least 90% you will get fairly decent answers back. And pretty much soon, probably you will have a thing where it's a lot more user friendly and stuff like that. But definitely we can discuss with Professor Deepthi.
Right. And I have just one more question. I'll trouble you just a little bit more. If you could send me names, because I'm willing to fund this. I'm actually from the UK and I'm willing to fund it. I'm willing to work with someone who can I can write the textbook in English and someone will help me translate it into Telugu. Because, it's time that we did something about it. And I'd love to do that. So could you share with me any names
Sure.
or any companies that do Telugu that were able to work with me?
Yes. I'll give you my professor's name, who's deeply working in this area. And let me type it here itself so that it is easier for you. You can send us a note and then I'll ask, because all these are part of the National Language Translation Mission. So most such use cases come, the government will be a lot more happy to support those
Okay.
initiatives. So that
I
way,
am so grateful to you and to the organizers for this FTP. I'm having such a great time. I'm goofing up on my classes, missing them so that I can attend this. Thank you.
I'm honored, ma'am. So that's their email ID, and you can shoot a mail copying me on this. Yeah, that is the. Someone else had a question. Someone raised a hand here.
Sir, this is Lucky Mishra from Ahmedabad.
Hi.
In MBA, yeah, sir, in MBA, in GTU, Gujarat Technological University, entrepreneurship subject is there. So that subject I'm dealing with. So in second semester it comes. What I was thinking that I'm attending the classes this FDP program from this 14. I'm finding that most of the startups, more than 90%, get failed. So I was thinking that incubation center is fine, but there must be some incubation plus so that the startups which are getting failed or not getting success. So for them, the incubation plus must be there. That is the thought which comes into my
Absolutely.
mind while attending these all classes. Yes, sir.
Absolutely. Because to enable this startup
Thank you,
ecosystem,
sir.
what we have done well, as an incubator, it's not just giving space, we also run acceleration programs, domain specific acceleration programs. And we have broken those acceleration programs into micro accelerator programs. That is, usual acceleration program is end to end, right? Right from problem, understanding the problem, understanding the customer, understanding the problem market, solution market fit. And that is a large program. So now someone wants to understand only finance. Someone wants to only understand because each startup has different requirements. So we created micro accelerators that has really helped in this. The second one we do is one needs to do is we do a lot of idea validation boot camps. Before they become a startup, to validate ideas, we run a 1 day program wherein investors, different mentors come in and give a quick validation of their ideas. Then we do a go-to-market boot camps because these people who are so those boot camps really help. The other one what we're doing is the entrepreneur residence program is basically a pre-incubator or a micro kind of an accelerator before they become a startup. So that because by the time they exit the pre-incubation program or a fellowship program, they're more or less ready because some of them failed before that itself. So they're more or less ready for it. The other one is the course that you talked about. Me and Professor Ramesh run a course called Technology Product Entrepreneurships. How to build companies from technology-based companies. So that's a 1 semester program. We have structured this program. I don't know how it is done in Gujarat Technical University. We'll be able to share more how we run it. Here, the entire program, the students come take one of the technologies from Triple IT, and then they try to build a company out of it. The the end semester exam is an investor pitch. So the deal is this: if the investor says I'll invest, they get 100 marks. Investor says I'm not going to invest, they get 0 marks. And of course, we give something. This is a conditional investment. We give something. So, those are some of the things that opens up. They may not. None of them may go because it's an academic course. None of them may go ahead and build a company, but it has opened them up to a variety of frameworks that they can look into so that when they build their own startup, they're ready with those frameworks and they're like more likely successful.
Thank you, sir.
Sir, I'm Dr. Malay Ghosh calling from BSSIS Bhopal. Actually,
Hi.
we are running the program in MBA.
Okay.
So basically, I need one guidance from you. We are basically going to start one incubation center at our institution. So, sir, can you guide us how best we can able to proceed with the things like what are the areas where we can able to explore from where the experts can be available, and what is
Yeah.
basically the ecosystem that is required? Because actually the knowledge is available, but the knowledge are not basically consolidated. We have to search out so many agencies, so many different departments. So if there is any kind of a particular agency or particular kind of the group of organizations where we can able to approach and can able to get some kind of a streamlined information at a
Okay. What
particular
I'll do
place.
is there are multiple things. I'm giving you the email ID of the person who is heading our outreach, Mr. Professor
Yeah,
Ramesh
yeah,
Yoganathan. So he is
yeah,
the
yeah.
authority in this, and he has been. So he'll be able to quickly point you to the right people because he runs the
Okay.
incubator and the outreach, right?
Yeah, yeah. So kind of you, sir. So kind of you. I'm so grateful to you, sir.
Sure, most welcome. We're happy when anywhere startups come out of technology. We're more than happy to help.
Absolutely, sir. Thanks a lot, sir. Thanks a lot, sir.
So if there are no further questions, can I take your leave? Okay, then. So it was absolute pleasure interacting with you. All the best for the rest of the FDP program. Thank you.
Thank you, sir. Thanks a lot, sir.
ఉన్నారు సార్. Thank you, sir. Thank you for your valuable words. Now the feedback link will be circulated. I request everyone to please fill the feedback link as soon as possible because we'll not be sharing it in WhatsApp. Please fill it here itself.